Great. We're going to get started here. So my name is Robert Starmer. I'm with Cumulus Technologies, and what we're going to look at today is something that we actually looked at last week. I was going to dive into Kata again because we got a bunch of it working, but it seemed like there were still some gaps and some inconsistencies. I'm going to spin up a cloud machine. I'm going to drop onto Packet just to get a machine up and running, and I guess we'll sort of get started there. No time like the present. Let me switch over to view so you guys can actually see what I'm doing here. Let's get these guys running and go ahead and run this to live. Okay. Yeah, hopefully that's working now. Great. So I'm going to jump on. I'm going to use Packet as the backing for this. Log into the back end. We'll pick a project. How about we'll do this one. Just going to add a new server real quick. Maybe next time we'll do Kubernetes. Why not? That's always fun. We're going to call this a Kata node. We could give it an actual domain name. We might do that later. I tend to do things in San Jose just because that's what I'm close to, and I'm just going to pick a little tiny instance. T1 small is fine. And why don't I try latest? I did not try latest last time. I think I did 1604. So we'll go ahead and deploy this guy. I actually haven't played around with Ubuntu 1804 at all. I don't know if any of you folks have, but I guess we can kind of see what comes out of that. Actually, I'm also going to pop open another window. Let me get out of this screen view, though. Just want to jump on Twitch just in case any of you guys are out there. See what's maybe going on. Just in case there's any chat, I figured it might not be a bad idea to actually jump on the system here and see what's happening there. All right, so as this instance is spinning up, we can jump back into the Kata pages. There's obviously a get started sort of document, and that's what we're really looking for. We're going to start with the install guide. My recollection is. I actually need to capture this in a document for you folks. There are some changes, and really, there were some minor inconsistencies, things that we weren't. Maybe I should try 1604 or 1710. Although I'm going to just try it with 18 and see what happens. Might as well. I mean, the point here is to try this more than it is to figure out if everything works 100% perfectly. Unless they don't actually have it in the release, but they should. We'll see. We'll give it a shot, right? We'll see what happens. We'll see what blows up. We'll also need to get Docker installed on this machine, and the easiest way to do that is still the get docker.shell script, which I think this is still where it is. Yeah. So this is a shell script that will launch basically all the resources that we're looking for. Should be able to deal with the particular OS. We'll see what happens when we get there. Is this guy up and running yet? No, still in progress. The cool thing about Packet is that it's actual hardware. The uncool thing is it does actually still take some time. It's actual hardware being provisioned, so it's not as instantaneous. We could have used DigitalOcean or Amazon or something else and been a little faster here. But I like the performance that I get out of the Packet machines, so I'll give that another minute to spin up. Anyway, if you ever use these online shell scripts, people do the curl to bash kind of magic to get these things installed, it's always a good idea to have a look at the script first. Often people even recommend, hey, why don't you just download it and then run it locally instead of being super fancy and not having a copy locally. It doesn't really matter. I mean, I've looked at this script before, and it just sort of runs through first trying to figure out exactly which version of things we were trying to install, and then it gets the bits and pieces installed. Great way for taking a machine that doesn't have a container environment on it and getting, in this case, Docker up and running cleanly. Yeah, so now we wait for the magic install system to finish doing its magic install for a machine. Anyway, in the interim, we can just pop into here and have a look at the following documentation, right? So for Ubuntu, I mean, the idea here is that we should be able to get this in a couple of commands. That would be great. And that'll get us a basic Kata environment. And then we're going to go with the Docker approach first. Actually, maybe we'll come back if there's time, depending on how quickly this goes. We might even spin up like a Minikube Kubernetes, or target something like that, and see about launching Kata on a Kubernetes environment and see what it looks like. It would be on the same machine, so I'll just do Minikube on top of 1804 and see about getting that working. Or actually probably just do kubeatom, single node kubeatom setup. Would be another approach. Anyway, we can try some of these things. We'll see what comes out of it. I've only got about a half hour today, 45 minutes maybe. But I think in that time we should at least be able to get the Kata bits up. I still need to get these guys to take the $signs out of this, because this would be another way to get Docker up and running, obviously. I like this script, though, because it does all the right things. It is actually maintained by Docker, so it's current. But yeah, we need to have Docker installed, so that's the first thing we're going to do. Let's see how our server's doing. Almost there. Almost there. We're going to get into this since I don't have my DNS automatically set up. We're going to go ahead and just grab this IP address for now, and I'll just go ahead and do an SSH. Get ready for that, because that's where we're going to go. All right, so this guy is now up and running. So we've got a green light for the node. So we'll go ahead and say, yeah, let's log in here. All right, so we're on our node. Like I said, the first thing we need to do is actually get this script, or following the Kata instructions, follow their downloads. So we can just get this. We'll put it into a file called docker.shell, and then we can bash docker.shell. And so this will go ahead and run all the required set of tasks. I mean, basically, it ends up doing the same thing that the script that we had here on the Kata page. I can get rid of that now. All right, so here for Docker, it said, hey, go ahead and install this. It's basically doing the same thing, same set of tasks. It's just that it's scripted, so I don't have to type the commands. All right, so looks like that's all good. Usually people think that we're not running in root, but since this is a cloud machine and not basically a desktop approach machine, I tend to have root access and log in as root. So it's never bad to use the sudo based commands even as root, especially if you start scripting your own things, but not something that I've been doing recently because, again, I live dangerously apparently. All right, so then the next thing we have to do is we do have to modify the Docker configuration. So the default Docker configuration needs to basically be aware of a runtime configuration. And one way of doing that is actually modifying the service documents. The Google gvisor stuff that we looked at last time, or in a previous session, was had a different approach, which was to actually configure the Docker the Docker system config for this. We'll go ahead and follow the We'll go ahead and follow the service. Now, one thing that's interesting is that here, not only are we saying, hey, there's a new runtime, basically a new way of running containers, which is what the Docker runtime really is, but we're also setting a default. We're saying that if you just do Docker run, it's going to use Kata containers for that. That's fine because the default, the other runtime, the sort of the defaultly plugged in runtime is run C, and we can still call that out in much the same way we would have called out a Kata runtime otherwise. But we'll go ahead and follow their instructions. We're gonna do what they say so that we can see if this actually works. Looks like we need to make a service directory if it doesn't exist. My guess is that it probably does not exist by default. We can actually do an ls first. So instead of this, let's just see if this directory exists first. No, so we can go ahead and make this directory. Great, so now we have a services directory. It's not, and then we can go ahead and grab all of this. And we'll go ahead and paste and run this. So this is a here file. Basically, this is saying cat and then suck in everything up to EOF terminator. And in this case, because we're trying to write it to a file system file, basically a root managed file, root user managed file, that's why we're also doing this pipe the output. Because when I cat this, when I express this to the screen, basically it's going to write this then into this file. So this is actually a pretty good trick from a non-root user perspective for how to actually write a system file with a here file. So basically it's going to say, hey, look, take all this stuff from the next line to this EOF terminator, and that can be anything. It just has to match and spit that into a file. So we're going to go ahead and do that. So what this has done is it's basically reset the Docker runtime. That's what this exec start does. First it says, hey, set it to nothing, and then go ahead and add this as the exec start command as a part of the service definition. All right, so now if we cat that file, we'll go ahead and grab this. Great, now we have that particular service definition. In order to actually read this, we have to do system control, does it reload? Daemons, no, I can't spell apparently. No, it's the other way around, see? And then we can do system control restart for our Docker service. And if everything goes well, since it seems it was happy, that means that now we have Docker running. And so the idea is if we kick off a Docker run, so for example, in this case, we'll go ahead and launch something simple like the BusyBox app. So we pull our image down and unhappy. Okay, so we missed something. Let me see if we can try this. Runtime is run C. Oh, what did I do? How did I get CH? Okay, so we can, so Docker is working properly. This is just checking with the run C runtime, but it's not happy with Kata runtime. Oh, I think we must have missed a step. I must have missed the, yeah, we never installed the Kata stuff. Docker, reload, wait. Set up Ubuntu, get Docker CE. All right, I know I saw it here. Oh, here. All right, we'll get there. I just jumped ahead because my machine hadn't been ready. So this is the one, my one little complaint with their docs. Why do I have $signs at the beginning of every command line? I have to copy and paste this stuff anyway, don't I? I just need to reach out to the community and say, hey, let's fix this. So what we're doing here, apparently OpenSUSE has this in their repositories, is we're saying, hey, look, let's add a Debian based packaging string to our sources list. So this is our Debian sources list. That's the first thing that we're going to do, and that's going to point at the code we need, basically a place where the Kata container code was added. We need to provide a key that'll provide security information, basically signing of the packages. That's always a good sign. That means that we know that at least they came from where we thought they came from. And then we're going to update our repository information, which is a pretty common operation. We'll let that run, and then we're going to go ahead and install the Kata resources. So now things might actually work. So here we go. This all looks good. It's not complaining about the release, so even though the docs only say 1604 and 1710, there is at least something for 1804, or at least it's not complaining about the 1804 release request. And yeah, so it's kind of interesting because not only do you download the Kata resources, but as a part of that, you're downloading QEMU Lite. It turns out that I think in the developer docs it said that's actually not necessary anymore, that the general QEMU runtime will actually now support this. But this is basically just the interfaces needed in order to run Kata. And last time we talked about Kata as effectively a hypervisor shim, and I don't remember if their docs, I don't think the Kata docs actually had, oh, actually maybe this is sort of what we're looking for. Yeah. So you know, here the classic virtual machine model is kind of what we're working with, but there's basically a more efficient process in that the shim that we're using is basically capturing all of the I/O requests. And sort of dealing with the connection to an actual virtual machine interface. Just sort of improves the security model because we're running through what is effectively still a hypervisor, even though what we're doing is launching a container on top. So a more efficient way of dealing with this effectively. And so if we go ahead and jump back here in our commands. So we had tried the run C one that showed us that Docker was still working, and now we'd set our default because we set the change in the system config to use Kata. So if this runs this time, which looks more promising, sure enough, now we're actually running, and that's kind of what we were looking for. Actually, now I'm curious as to what the run C version gave us instead. There was run C. Yeah, so here is something that's interesting, right? So this is the Linux kernel that actually should be the same as ours if we do uname A. Yeah, so this is the machine kernel, right? If I run Docker, I'm actually talking to the underlying operating system machine kernel. And that's what I'm seeing here. So when I'm saying use run C, that's using the generic Docker configuration. And so here we're using the run C kernel. If I do it in Kata, though, I'm using a special kernel, basically a pre-compiled kernel that is the interface layer between the container. This is still a BusyBox container. Right? This is still a Docker container that we're running. Nothing changed there. But we're now running it on top of a shim kernel. And so that kernel is where we're actually doing our security segregation. And the cool thing about that is that now I have a full Linux kernel. This is 4.14. Okay, so it's ever so slightly older than the one that we're currently running. But that's actually just as buildable and updatable as any other Linux kernel that we're using. So we could update that to 4.15 as well if we wanted to. And that's sort of part of the process. We could actually jump back into the docs. I think the other thing to do, though, we said we were going to look at possibly launching a a Kubernetes-based version of this. Really, the only thing that's different then is the control plane. Is how am I actually talking to this environment? Because all we're going to do is change the runtime from run C to Kata. But let's go ahead and see. I'm always interested in understanding how somebody's documentation works. Let's see what the Kubernetes docs suggest for how to get our Kubernetes environment up and running. This looks like a much longer run. Well, we'll see if we have time to get through this. I do think it's kind of interesting. We do have, this is actually more like how to actually go through and build all these pieces. So let's see, what are the processes here? It looks more like the developer guide. Okay, so here it's actually going through the process of building out this code directly. But if we jump down to the install Kubernetes section, which is probably what they actually meant for us to go look at, because we have all of this installed, right? So we have our resources installed and running. We don't have the CRI-O stuff though, so maybe we do have to do some of this. Here we go. So container runtime initiative, this is the open version of Docker, effectively. So this is part of the Cloud Native Compute Foundation's approach to running containers. The OCI is Open Container Initiative, and container runtime, maybe it's container runtime interface. I think the I's were always interfaces. But anyway, so we do have to make sure that we have that installed. Okay, so we do have to install something new here. So they're suggesting CRI-O as the initiative. And it looks like we need to go through the process of installing it. So let's go ahead and jump into seeing what that looks like. So we have a machine running it. All right, well, we already have run C. Let's see if our version of run C is appropriate. Oh, it doesn't even want to let us use the Docker one. Okay, well, we can go get this one. Actually, before we do that, I want to see what other versions are available. Because why use an old one if we don't need to? See, there's RC5 already. Why would we use RC4? Okay, we do want AMD 64, so we'll go ahead and just copy this link. We could also copy the checksum, but I'm gonna live dangerously here. -O run C. And I think that's actually the binary. So user local bin is where I put things, and we'll call it run C directly. We should make that executable, so it's change mod plus x /user /local /bin /run C. And so now if we do run C-v, we should hopefully get, okay, great, we're at 105. Perfect. We've got a run C that we can use. Yeah, okay. Well, I did it a little differently, but same difference. Okay, then we need CRI-O. So we need a version of Go. All right. I think I'd rather get a newer version of Go than 185, but well, I mean, this is for their purposes, so we might as well go ahead and get what they're recommending. Although no, I'm not going to do that. Ubuntu. Yeah, okay. Hey, Stack Overflow, why not? No, I don't want that one. Okay. Oh, come on. Oh, there's a 1.10 now. Oh, well, this is PPA. There was some trick even here. It's like when you install it, it still doesn't put it where you think it is going to put it. Don't think we need that. Yeah, so there's just this trick here. Well, we could try a snap. Hey, let's try all kinds of crazy things today. Yeah, except Snap's not installed by default on server, which is just, you know, classic Ubuntu. I'll try this. Try this version of Go. Or not. All right. You know what? I'm reading this loud and clear. Just follow this process. Okay. No, that didn't copy it. Okay. Let's try this way. Ah. There. Get the new version. Extract that. And out of this, we should get a... oh, that's a cleverer way to do it. All right, so how about we... I think if we start with Go, does that do it? So that's what it's going to extract, all this stuff. But it's all under the Go directory, and so that's yeah, all right, well. And view verbose there. All right. All right, so we have Go running. We need to make a Go directory. Go path equals export path equals we want our path, and then we want our Go path bin. Source that. All right, so what we've done is we've installed Go in user local bin, so we have Go version, right? So Go runs. We've also set up our bash so that Go path points to a Go directory. So we need to make a directory called Go. We can make a directory Go bin and Go source. Those are sort of the core pieces of getting Go to work. Yeah, so here we want to make sure that we have our paths defined, source, and well, they don't talk about bin, but they should. Anyway, so we have Go. So now we can go grab our GitHub stuff, and we're going to do this with Go. So this is Go installing the CRI tools, and oh, it's actually building this stuff. So we'll see if we have the right tools installed. Right, apt-get install. Okay, so we need Git and GCC at a minimum. Yep. As I said, we'll see how far we get with this, but at least so far, we're making some progress. All right, assuming that we have those tools installed, that's just for the control, and then we need to install a bunch of stuff in order to actually install CRI. Wow, this is so easy, right? Everybody wants to do this, I'm sure, in order to get their runtime working with Kubernetes. Although, I think that this will get a lot easier pretty quickly because the Kubernetes community seems to be pushing towards the CRI-O or I think it's CRI-O over Containerd, but one or the other. I think the community wants to have sort of a cleaner interface because having Kubernetes run Docker to run runc is overkill when there are other approaches to doing that. And I think this is actually not the easiest way of doing this, but it is certainly a part of how I believe people are going to be expecting to run Kubernetes in the near future. So yeah, running through this in the painful fashion now means that we're a little bit on the early side. But you know, that's maybe the way it is. Okay, so now we have git. So the go command to basically do a git clone is working. So we'll go ahead and let that clone itself, and then we'll let the pieces continue to download. So basically, it's doing a clone. It's changing into the directory. So basically, we're logging into that directory that gets created, and then we're running the make command, which basically uses the make tool and the make file, which is basically a description file, to actually get our tools installed. And then last thing we do is we run a make install. That actually does the installation process. So now we have our CRI tool, CRI control. Great, but we don't have CRI running yet. And it looks like in order to do that, is there a way to just install it? No, looks like even here we still basically have to go through this process. So we're going to go ahead and install, oh, now you tell me to do this. We're going to go ahead and install the other tools that are needed for this build. So two things to fix. One is to tell the Kata folks that they need to remove the $ in front of their copy and paste command lists, just make our lives easier. And the second is to tell the CRI guys that in order to do go get, you still need to have git, and we need to have make, and so we should install that as well in advance of telling us to run a tool. All right, so that's installed the tool pieces that they believe we need. Basically, it's a bunch of additional libraries in order to be able to support our tool. And now we can basically do the same thing we did for the CRI command line, CRI control or CRI cuddle, depending on whose thing you focus on. No go files. Incubator. Huh. Well, let's go see what's here. Why did this not work? Have these instructions changed? It's not scope, commands, configuration. Hey, look, clear containers, which is what we're building Kata on. Okay. They have actually a much larger list. Why don't we get all of this? Oh, and then they even say this, huh? Well, huh. I'm going to try this because I think we probably have. Okay, so we have the download. So we can just try and see if we have the right tools, or do we need something else still? Because clearly the list that the CRI-O project has is much longer than what this other set of instructions is we're looking for. Yeah, I guess we do need this larger list. Okay. Looks like 1804 actually includes Golang 110, so all that mess of trying to find Golang is absolutely unnecessary. Different version of run C, but that's okay. Looks like there was a complaint about a module, but this is an underlying Linux kernel module that may or may not be a problem for us. I don't think it's an issue. We're not restarting the machine. So in this case, it's just because I think because we installed these tools, it's actually trying to rebuild the init. Yeah, but that shouldn't be a problem for us. We're not messing with that. Okay, well we can try. I don't know about this libos tree dev package. I don't know if that's going to bite us, but all right, we're going to give this one more shot. Coming back to here, install tools, make install. Okay, which was basically what we had tried earlier. Gonna try to turn on a bunch of security. I guess we'll see if that works. Well, that does look like that built. So we can do make install. That should try to put all the pieces in the right place. Do that too, looks like. That's probably a good thing to do. Once the install finishes. This is where a bigger machine would have helped, but this is sort of one of those few places where a bigger computer would help, just to speed up the output. This, I believe, is still based on an Atom processor, these packet machines, but look, install's done. Now it said install the configs, which apparently means that it redoes the install build. Okay, great. All right, so we should have our configs installed, and let's see. Validate options. Sure, let's make sure that our system is running CRI-O. And then we can do reload, enable, and start. Those are all. Okay. not like that. Oh. That looks promising. All right. All right, so our CRI-O environment says it's running, so that's a good sign. Yeah, let's not deal with any of that. We're going to jump back here. I only just have another minute or so today, so we got CRI running. Yeah, and the next step would be to install Kubernetes and then connect the two things together. Anyway, actually, I am basically out of time, so we're going to call it for today. But the next step, I think next week I'll have some more time, and maybe we'll just dive into this. We'll get back to this state, and we'll get our Kata runtime running underneath Kubernetes with CRI-O. Since the instructions are mostly there, maybe we can clean them up and post them somewhere as well. Anyway, hopefully that was useful. Tune in next week, same time. We try to do this 9 a.m. Pacific. I think the previous week didn't quite work, and we will of course also drop this onto YouTube. If you're interested in this kind of education, looking at these sorts of tools, you might want to check out our classes. We have them on either Udemy. You can find some of our stuff there. Look for Kumulus as the instructor, or learn.kumul.us. Either way, really look forward to having you join our stream next time. Thanks so much.